There are two types of electricity, AC and DC, but transformers can only work using AC or alternating current. When we connect an AC generator to a closed loop of cable, a current will be able to flow through this cable and the direction of the current will alternate backwards and forwards with the rotation of the generator. The alternation means that the current reaches its maximum and minimum point during the cycle, which gives it its sine wave pattern when connected to an oscilloscope. Now you can think of this as the tide of the sea as it changes direction and reaches its maximum and minimum point. As the current flows through the cable, it will emit a magnetic field. If we pass DC current through the cable, the magnetic field will remain constant, but if we pass AC current through the cable, then the magnetic field will increase and decrease in strength and changes polarity as the current changes direction. If we place multiple cables together and pass current through them, then the magnetic fields will combine to create a stronger magnetic field. If we then wrap the cable into a coil, the magnetic field will become even stronger. If we then place a second coil in close proximity to the first coil and then we pass AC alternating current through the first coil, then the magnetic field it creates will induce a current into the second coil, and this magnetic force will push and pull on the free electrons, forcing them to move. The key component here is that the magnetic field is changing polarity as well as intensity. This change in intensity and direction of the magnetic field constantly disturbs the free electrons in the secondary coil, and this forces them to move. This movement is known as electromotive force, or EMF. Electromotive force does not occur when we pass DC current through the primary coil, and that's because the magnetic field is constant, so the electrons are not being forced to move. The only time it will cause EMF is very briefly when the primary circuit is opened and closed, or when the voltage is increased or decreased, and that's because these actions result in a change to the magnetic field. Therefore, we use alternating current as this change occurs constantly. Now the problem with this setup is that a lot of the magnetic field from the primary side is being wasted because it's not in range of the secondary coil. So, to fix this, engineers place a core of ferromagnetic material such as iron in a loop between the primary and secondary coils. Now this loop guides the magnetic field along a path to the secondary coil so that they will share the magnetic field, and this makes the transformer much more efficient. Now the use of an iron core is not a perfect solution. Some energy will be lost through something known as eddy currents, where the current swirls around the core and this heats up the transformer. And this means that the energy is lost as heat. To reduce this, engineers use laminated sheets of iron to form the core, and this greatly reduces the eddy currents.